It's day 27, Thursday, February 27th, and this is probably going to be one of the very last lessons I teach you because next week is finals week. So that's exciting. So today we are looking at sets of binomials. I only said that word maybe once yesterday. So if you are thinking that this is a word you've never heard before, I'm going to explain what this means again. A binomial, if we break it down into two parts, bi means two, and nomial is a fancy word for numbers or terms. So because in each of these problems, in each set of parentheses, there are two terms, these are all binomials. So just a little fun fact for you. So let's look at number 1. I have 5x plus 1 times 2x plus 3, and I'm wanting to use the FOIL method to do this. Does anybody feel confident in being able to lead the class in how to solve number 1?
I'll try it, but I know it's wrong.
Oh, don't say that. It might not be. Let's see. Okay, so what am I going to do first?
Okay, we're going to do the FOIL. So the first one is first. We're going to take the 5x and take it over to the 2x.
5x and 2x.
And then the next one is the outer. So we're going to take the 5x over to the 3.
Okay. So there's our first two steps, the F and the O.
So then we can go ahead if we want to and do 5x times 2x. Write it down.
Yes, okay, so 5x times 2x.
Which is 7x.
So 5 plus 2 is 7.
Oh, that's right. I did that wrong. I knew I did it wrong.
Okay.
5 times 2 is 10x.
Perfect. So 5 times 2 is 10. And then x times x is
2.
X.
So it's 10 to the second power.
Yes, good. 10x squared.
So I would have got that one wrong, but I
Just
still
see, I
got
have
it.
printouts of what we're doing right now at the front. So perfect. We have 10x squared. That was 5x times 2x. And all right, your next step you told me, 5x times 3. What's 5x times 3?
Yeah, 15.
Yes. 15x. Good.
Got that right.
Perfect.
Okay. Then we're going to go, and then we're going to do the inner, which is 1 times 2x.
Perfect. 1 times 2x.
Then we're going to do the last, which is 1 times 3.
Good. Plus 1 times 3. It's really nice when we have 1 as one of our terms because whenever we multiply anything by 1, it doesn't change. So what's 1 times 2x?
3x.
1 times.
Oh, I'm sorry. 3. Yeah, 3.
So the last
It's
term
a 2x.
right here
I'm
is
sorry.
3.
I'm
No,
sorry.
you're okay.
It's a 2x.
You're okay. You were just jumping ahead. That's correct. 2x plus 1 times 3 is 3. All right. So we did the hard part. We did the FOIL.
Now I'm going to go to the 15x and the 2x and underline because we're going to combine that.
Yes. 15x plus 2x will combine. And what will that give us?
18x. Oh, I counted wrong.
You're
I'm
okay.
sorry. 50, 16, 17. I'm sorry. My bad.
17x. Good. So I'm going to rewrite everything. I will get
bring everything down.
10x squared plus 17x plus 3.
And then you circle it.
There it is. Awesome. Thank you, Jimmy. That was perfect. Perfect. Good. Okay. Any questions on number 1? Did anyone get a different answer than this and is not sure how they got a different answer? Okay, please remember at any time, if you are not sure why I wrote something down, you don't know what I'm saying, let me know. I don't mind explaining. I actually love explaining because it helps me know what you guys need more help with, and it helps your classmates as well. So, all right, that's number one. Let's go ahead and look at number two. X plus 2 times x minus 2. Would somebody like to lead me through this one?
Right.
Okay, go ahead. How am I going to start?
Okay, so first we are going to, it's going to be x times x, which is x2.
Good. So x times x, and that'll give us x squared.
And then we're going to do the outer, which is going to be negative 2x
Yeah. So we're doing
minus
x times negative 2, which gives us negative 2x. Good.
And then we're going to do the inner, which is positive 2x, so plus 2x.
Gives us 2x.
And then the outer, or the last is minus 2.
And so 2 times
Negative 2.
negative 2.
Oh, it's going to be negative 4.
Yes, good catch. Good catch. 2 times negative 2, that gives us negative 4. Okay. So,
So then your negative 2x and your positive 2x is going to cancel out.
yes. Yes.
So that means your answer is x to the second power minus 4.
Perfect. So, remember, anytime we get a middle term where we have minus something x plus something x, and it's the same number but opposite signs, those will cancel out. 2 minus 2 is 0. 0x, 0 disappears. We're gone. We have now x squared minus 4. Perfect. Good job, Amanda. That's perfect. Okay. These can be a little bit tricky. I put one of these on one of the exit tickets. It might have been yesterday's. And I know. So yesterday's exit ticket, everyone that I've graded has gotten a 10 out of 10, which is amazing. But I know before getting the 10 out of 10, there were some corrections to make where a few of us forgot that a minus 2x plus 2x cancel. That's just a rule of math, guys. If there's anything we can do to practice with that some more, we can do that. Do we have any questions on number 2? Okay. Can I move to number 3, or does anybody still need to see this work? Okay. And then there's number 3. You show these? Okay. Number 3, I have 3x minus 1 times x minus 4. Would somebody else like to lead me through this one?
3x.
X. Perfect. We're into the first terms, which is 3x and x. That was it. That was it. That's a good first step. That's perfect.
That was pretty good.
Okay, so that was our first terms. What comes next?
3x squared.
Oh yes, 3x times x does give us 3x squared.
3x times negative 4.
Yes, our outer terms are next. 3x times negative 4.
Negative 12x.
3 times 4 is 12. It's negative plus there's an x. So minus 12x.
Negative 1 times x is negative 1x.
Good. So my inner term here, negative 1 times x. So gives us negative 1x.
-1 times -4 is +4.
Perfect. So now we have -1 times -4. And that gives us the negatives cancel, positive +4. Okay. So we did our first, our outer, our inner, and our last. Now, what do we do next?
Combine like terms.
Combine like terms.
-13.
Good. I have negative 12x minus 1x. Negative 12 minus 1. It's just like negative 12 plus negative 1. Negative 13. Very nice. So we'll bring everything down. 3x squared minus 13x plus 4. That is our answer. Any questions about number 3?
I had all of it right, but the first one, because I always get mixed up about them X, the X.
The
And
x's.
then making it a square when I add the two of them, I always, that, so later on you need to do some more of them. But I had all the rest right.
Well, good.
It just wasn't, that first one wasn't right.
Oh, that's all right. So the exponent rules, I do want to mention, just to make you feel a little better. We literally just yesterday and a teeny tiny bit on Tuesday for the very first time introduced exponent multiplication rules. So the fact that you guys are doing this good already is amazing. You're doing great. It's definitely not a problem that we're still struggling just a little bit to remember some of those because it is new. You guys are doing wonderful. Anything else on number 3? Okay, number 4. This is the challenge question because now our first binomial starts with not just 3x, it's 3x squared. So before we go through solving this, can we tell what exponent our first term of our new answer is going to have? What will that number of the exponent be?
3.
3. It'll be to the third power. How did you know that?
Adding 2 plus 1.
Yes. So since our first term of our first binomial is 3x squared, there's a 2 there. And this first term of the next one is 4x to the first power. We're just adding, there's 2 x's, there's 1 x. Now we're going to have 3 x's, x to the third power. So let's go through solving this one. Same process with FOIL. So my first terms are 3x squared and what?
4x.
4x. So, and I'm going to write a little lower. 3x squared times 4x.
X to the third power.
Good. 12x to the third power. And what comes next?
3x squared times -1.
Good. 3x squared times -1. -1.
It's -3x squared.
Good. So -3x squared. We've done our first, we've done our outer. What's next?
3 times 4x.
My inner terms, 3 and 4x. So 12x, good. 3 times 4x. So 3 times 4 is 12, and there's an x, so 12x. And last one, what is it?
3 times -1.
Good. My last terms are 3 times -1, which gives us what?
-3.
-3. Okay. Do we have like terms to combine?
3x squared and 4. Oh wait, Club.
Ooh.
No.
Let's see. So remind me, what is a like term? What makes something like?
They all got to be the same.
They have to be the same. In what way?
In the number and the square.
In the number
Well,
and
you-
square?
Well, you know.
Variable.
Okay,
Yes.
I'm sorry.
No, yes, I know what you mean. The like term qualifier, what makes it a like term is that it has the same variable. Now, these all do have the same variable, these three, but they also have to have the same exponent. So I have a 3 here. I have a 2 here. This would be a 1 here. None of those are the same. So we actually don't have any like terms here, and we are done. This would already be the answer. So I'm just going to rewrite it under there without all that extra writing and circle it. So 12x to the third power minus 3x to the second power plus 12x minus 3. Now, I have a super challenge question for you guys. Does this new, I'm going to give you another word. This is called a polynomial. Poly means many, nomial term. So this is more than 2. So this is a polynomial. You don't have to know that, but I'm just telling you so I have a name to call it. Polynomial, if you're curious. Does this polynomial have a greatest common factor?
3.
3! So, just for fun, if I wanted to factor this, not factor completely, if I were to factor it completely, I would get this, but I'm not going to teach you how to do that yet. That is Algebra 2, and that is a long process. Let's factor out the greatest common factor, though, the GCF. So we said 3 is the biggest number that will fit into all of these, right? Okay, so if I picked 3 as my GCF, how would I write this in factored form?
You would divide all the numbers by 3.
Divide everything by 3. Okay, and whenever I write out my answer with the parentheses, where does that 3 go in my answer?
Front.
Right in front, outside of the parentheses. And how do I get what goes inside?
Divide.
I do that division. So 12x to the third power divided by 3, what does that give us?
4x to the third power.
Yes, 12 divided by 3 is 4. We're not dividing any x's or any exponents. So all of our exponents and our variables will stay the same. So I'm going to get 4x to the third power. What's our next term?
Would it just be x to the second power?
It would be x to the second power, but we're missing
Minus.
minus. Good. So this is like -3 divided by 3, which is -1. So we're going to have minus 1x squared or minus x squared. Perfect. 2 more.
Plus 4x.
Plus 4x. Good. Minus 1. Amazing. That's awesome. Okay. So I didn't ask you to do this on the do now. This was just for a little extra practice, see if we could do it. But this would be what it would look like if we decided to factor out the greatest common factor. Pretty cool. Okay, guys. That's our do now. Does anyone need me to display this for a moment to write any of this work before I move the page? I'm going to move. Okay. We're going to do a little bit of notes here. I'm going to teach you a new method for how to solve these problems. And if you are a more visual person, I find that a lot of my students prefer this method. But it's a personal preference. You might like it way more, you might hate it and never use it. It doesn't matter. You can do whichever one you like best. So let's highlight those. Day 27 notes. Okay. So we are, hello. We just started taking notes, so you came just in time. Just in time. So we've been using the FOIL method. I'm going to show you a new method called the box method. Multiplying binomials. So let's see. Here's how we use the box method. If I were to start off with two binomials being multiplied, such as, let's do 2x plus 1 times x plus 4. Here's how the box method would work. Instead of doing FOIL, where I'm doing first, outer, inner, last, I'm going to start by drawing a box. And that box is going to look kind of like a window because I'm going to give it 4 sections. I'll cut it in half vertically and horizontally. Like this. And here is how I'm going to use the box. I am going to start by taking my first binomial and writing it on top, lining it up with the boxes. So my first term is 2x. So right above this first box right here, I'm writing 2x. And in the second area above the boxes, I'm going to write plus 1. Then I am going to take my second binomial and I'm going to write it on the side of the box. So right here in the first row, I'm going to write my first term, which is an x. And my second term is positive 4. So I will write below it plus 4. So here's our layout. I've taken my problem and I've put it near a box. I want everybody to get that copied down because I don't want to start showing you how to do it and then you look up and you don't know what I did. Now, this box method is going to work just like a multiplication table. Everybody should have one of these at your tables. If you've never seen a multiplication chart, here it is, and I'm going to show you just real quickly how it works. Basically, we have numbers going across from 1 to 12, and then we have numbers going from top to bottom, 1 to 12. Whenever I look, for example, at 5, if I go down to the second row, this will give you the answer to 5 times 1, 5. The next row will give me 5 times 2, 10. The third row will give me 5 times 3, 15. 5 times 4, 20, and so on and so forth. So we're just following down and across and multiplying these numbers on the outside. So that's how we use a multiplication chart. And we're going to take that method over to our box here. So I'm going to start top left-hand side and go to the right and then the bottom over. So right here, I am multiplying 2x times x. What is 2x times x?
2x by 2.
2x squared. Good.
Sure.
Next, we can go over here. What two terms am I multiplying in this box?
1x.
1 and x. What's 1 times x?
1x.
1x. So I'm going to write plus 1x. Okay, then I'm going to go to the box below this here. What am I multiplying in this box?
2x
Uh-huh.
with 4.
Yes. 2x times 4, which gives us what? 8x. Good. Plus 8x. And what am I multiplying in my final box?
1 with 4.
1 times 4, which is what? 4. So now I have all of my terms. And what's nice about the box method is the terms that we need to combine, our like terms, will usually fall on this diagonal, 8x and 1x. So we can write our final answer now, going from the top to the bottom. I have 2x squared. So I'm going to write that out over here. 2x squared plus, I have 8x and 1x. I'll combine those to get what? 9x. Good. Plus what?
4.
Plus 4. And that would be my answer. So this is just a different way of doing it. Some people like this method more. Some people don't like this method. We'll do it a few more times together. But it's really just a personal preference. I don't care which one you use.
This is on Monday,
You like this one better?
Yeah.
Tuesday, or Wednesday.
It's here now. It's here now. Okay, let's do another.
Wait, you've been holding on to this whole time?
I guess so.
Wow.
But now we know it. Let's try 5x minus 3 times 2x plus 2. So we'll start by drawing a box with 4 slots in it. A window box. Once you've got that problem written down and your box drawn, tell me, what am I going to write above my top left-hand box right here?
5x.
5x, good. And what about the next box over here?
-3.
Good, minus 3 or negative 3. So there's that one. And Where do I write these next two terms?
2x goes right there where your pin is.
Perfect. 2x goes here.
Then under the plus 2.
Perfect. Plus 2. Awesome. Okay. So, in my first box, the one that is right here, which two terms do I multiply?
5x and 2x.
5x and 2x. What is 5x times 2x?
Yeah.
10.
To the second power.
Yes, 10x to the second power, 10x squared. Now, what do I multiply for my second box here?
3
Mm-hmm.
to the 2x.
Good. Negative 3 times 2x, what does that give us?
6x.
Negative 6x. Good. All right. What do I multiply down here?
2 times 5x.
2 times 5x, which is
10x.
10x. And last but not least,
2 times negative 3.
which is
Negative 6.
negative 6. Good. Perfect. Okay, so we have multiplied all of our terms. Which are the like terms?
X and then negative 6.
Good. I have 10x, negative 6x, or minus 6x. So, let's see. What is 10x minus 6x?
Positive 4x.
Positive 4x. Let's write that out to the side. Now, how will I write out my final answer?
10x squared
Mm-hmm.
plus 4x minus 6.
Good. 10x squared plus 4x minus 6. That is it. Wonderful. Do we have a greatest common factor here?
2.
2. We do. So just for fun, let's take it out. 5 by 2. And what would my answer look like?
Same as your question.
Really similar to my question.
5x squared plus
Yes.
2x minus 3.
Good. So 10 divided by 2 is 5. X squared. 4 over 2 is plus 2x. 6, 2, 3. Okay, so, and then I gotta put my GCF outside. It's not exactly what we started with because we are now looking at two binomials. Now, whenever we take out the greatest common factor, we're not going to get quite all the way back to our original problem because we have not learned how to factor completely yet, because that is a very long process and it's more of an Algebra 2 topic. But you can see there are some similarities between what we just got and our original problem. We have a 5x squared, 2x, 2x, minus 3, and there's the 2. Kind of interesting, all the numbers are there, but, okay. All right, let's do one more together, and then I'm going to have you guys try some on your own here in a minute. And I am looking at the time, it's 10:09, in case any of you weren't in here when I said this earlier. We have to take staff pictures today, and they're doing it right now. So after this practice problem, I'll probably give you guys a break. Because I need to go and put my Excel shirt on. Let's see. I'll give you a tricky one. It's super challenge. Although it might not be a challenge for you guys, I bet you can do it. Okay. So I have 3x squared plus 2x. That's my first term right here, or my first binomial. The second one is x plus 5. Do I write first?
3x to the.
Yes,
to
go
the
ahead.
2 power, whatever.
3x squared.
Yeah,
What do I write here?
2x.
Good. 2x.
Down in the first box to your left is x
Good. X
and a 5.
plus 5. Perfect. Now, writing the plus sign is optional. I always like to do it just to make it intentional, and it helps me remember that I am doing either a positive or a negative number on those boxes. But you don't have to write it. So, in my first box here, what 2 terms do I multiply?
3x, 5, 2.
So my 3x squared times what? Times x. What's that going to give me?
3x to the third power.
Good. 3x to the third power. Now go over to the right. What do I multiply here?
X times 2x.
Good. X times 2x. What does that give us?
2x to the second power.
2x to the second power. What next?
Times 3x squared.
Okay, 5 times 3x squared gives me what?
15x squared.
15x squared. And last but not least,
5 times 2x. 10x.
perfect. 5 times 2x is 10x. Okay. Do I have any like terms?
15x squared. 2x squared.
Good.
Equals 17 to the fourth x.
So let's see. Let's start writing out our thing. So 15x squared plus 2x squared. You said it was 17x what?
To the fourth.
Now are we multiplying here? When we combine like terms, should our exponent change?
No.
No, it won't change. Just like in all these problems, we started with x, we added or subtracted an x, we got x to stay. X, it stays x. Even though we have x squared now, we're only adding 15x squared plus 2x squared. So we are just adding 15 plus 2, and those are referring to the x's. That exponent only changes when we multiply. So it's just going to be 17x squared as our middle term. Does that make sense, everybody? Okay, it doesn't make sense. So what part of it has you confused?
There are two different numbers and two different exponents. Why wouldn't you change the exponent?
So
Then when you get the answer, now you have less exponents than you started with.
because our first term is still 3x to the third power, which is what we started with, or which is bigger than what we started with. So whenever we are combining like terms, let me actually just write this whole thing out as a problem because I think it might help. 3x to the third power plus 2x squared plus 15x squared plus 10x. So our like terms are the ones with x squareds. So 2 and 15. Now, if I add like terms, remember, we're saying that there are 2 x squareds, and there are 15 x squareds. It's like saying x to the 3rd power is green, x to the 2nd power is pink, and x is orange. If this makes any sense, hopefully it doesn't make it more confusing, but whenever I am combining my terms that are alike, my x squareds, these are alike, it's like if I have 2 pinks and 15 pinks, 2 plus 15 is 17, I should have 17 pinks. Does the color change though? Should it change into a different shade of pink or something?
No.
No. That variable, that term that tells us it's a like term, does not change when we add. It only changes when we multiply. Because x squared times x squared would give us x to the 4th power. But x squared plus x squared, now I have 2 x squareds. We only change the exponent when we multiply. When we add, we change the coefficient because it tells us how many of those we have. Does that make sense?
Yeah, but math is weird.
It is weird. It's so weird. And it's super confusing, especially because we are having to learn this trick where when we multiply exponents, we add. So then it's like, oh, so when we add, do we also multiply and then add? And then it's so easy to get it all mixed up. It's so easy to mix it up. Plus, this is the first one we've ever done where our like terms have an exponent on it. So as long as we understand now, that's good. We're learning. Math is weird, though. It's weird. So our final answer, what is it going to be when I write it out? I'll write my first term, 3x to the 3rd power plus what? Good, 17x squared plus 10x. Beautiful. Awesome job. There it is. Good job, guys. That is wonderful. All right. It is 10:17. That was the last problem we're going to do together. I can give you guys some practice problems to try on your own. There won't be an exit ticket today. It is Thursday. Yesterday was the last exit ticket that I will give you. Next week, we're just doing finals? Yes.
Can you give me practice on all of them? This is like the first lesson.
Yes.
It's hard for me to understand, but the second 2 lessons you taught, I'm catching it.
Good. Well, I'm glad you're catching it. So the very first lesson, are you talking about Monday? When I wasn't here?
I think Monday. No, I think Tuesday.
Tuesday. Okay. So Tuesday was the day that I realized I tried to teach you how to factor without going over exponent multiplication rules. So I bet Tuesday didn't make a lot of sense to many of us. I will get you some practice and we will go over some more of those. Anything that is new, I will make sure that we do tons of examples for anything that will be on the final. And I'll make sure to communicate that with you guys as well. So I'm going to pause our video here and we're going to take a little break and then we'll be back. So, all right, we are back. Oops, make that small. Okay, so I gave you a worksheet that I needed. Yes. There's lots of practice on here. 18 problems to be specific. And if you're watching this from home or just at a later time, ask me for this worksheet if you want it. I can give it to you. And let's look at these. So I'm going to start us with number 1. I'm going to zoom. It's kind of little. So let's see. we try some more of the box method. I'm gonna start by giving myself a little box. Getting your pen, since this is a small. Okay. So on number 1, I have 3n plus 2 times n plus 3. What should I write first on my box?
3n at the top.
Yeah.
3 next to it plus 2.
Yes, 3n and then plus 2.
And on the side of that 3n, the n
N,
on the bottom plus 3.
perfect, plus 3. Okay, I need something even smaller. My boxes are little. Let's see. This n. Okay, what am I multiplying in my first box?
3n with the n.
Yes, 3n times n. What does that give me?
3n to the power 2.
Yes, 3n to the second power, or 3n squared.
Then the 2 times the n.
Mm-hmm. What's that give us?
2n.
2n. What do we multiply down here?
2 and 3.
So I have 3.
3n and then plus the 3n and the 3.
Yes, we're going to do 3n and 3. So what's that?
9n.
9n. Good. And last box, what do we multiply?
Times 3.
2 times 3, and that is 6.
6, I mean, yeah.
Good. Okay,
And we're
so
gonna circle the n, at the middle one's 2n.
yes,
9n.
2n and 9n.
We're gonna add them.
Mm-hmm. What's 2n plus 9n? 11n. Now, what's our final answer going to be?
3n to the second power
Good.
plus 11n
Plus 11n
plus 6.
plus 6.
So you can do it different ways to get that answer.
Did you do it different and get the same answer?
Yeah,
How'd you do it?
I did the distribution of multiplication in there.
Okay, so did you write your numbers on a different spot, or?
I just put the 3n times. I did the FOIL method.
Oh, you did the FOIL method. Okay, and yes, the FOIL method and the box method are interchangeable. You can use one or the other and you'll get the same answer, which is what's nice about it, because if you don't like the box method, you never have to use it. If you don't like the FOIL method, you never have to use it. You just have to know how to do one of them. So
Okay.
that's what's good about it. They're the same thing, just written differently. So, let me get rid of the box. I guess I don't need that. But if we were to FOIL this one, we would come out with the exact same answer. Okay. Do we have any questions on number 1? Get number 2 then. N minus 1 times 2n minus 2.
So it's just easier to do the box.
It depends on your preference. Some people think it's easier to do the box. Some people think it's extra work to draw a box and write it all out that way. I think the more practice we do, everybody seems to kind of pick a favorite method. Sometimes it just depends on the problem. But yeah, it's every person is different. They all
She
prefer
taught,
different
she
things.
taught both.
Yeah.
But today, this one here just helped me better. I can do it
Right.
both ways, Keith, but this one just helps me
That's
better.
what I was thinking. I think the
Right.
box will help me too.
Sometimes it helps us stay a little more organized with it because everything lines up real nice. So on number 2, what should I write on top? N and minus 1 And then what?
2n on the side and -2.
-2. So what do we multiply first?
2n times.
2 in,
Okay. 2n times n.
with the little tiny 2.
Yes, so it will
I'm
be
just gonna say tiny 2.
2n with the tiny 2. 2n squared.
Yeah,
Perfect.
tiny 2.
What comes next here?
1 in, -1.
Ah, we have -1.
Wait, take that back. Okay,
-2n.
just ignore me.
-1 times 2n. What does that give us?
-2.
-2n. 2n. And what do I multiply here?
-1 to -2.
-1 and -2 would be in this box.
Yeah,
Or,
-2.
yeah,
N times -2 gives us what?
-2n.
-2n again. And then Lisa, what will we get on our last box?
now you do -2.
Yes. -2 times -1 is
2.
2.
Hey,
A lot of 2's on this one.
how many 2's?
So, do we have any like terms?
Yes, today.
Yeah, I don't. Right here. What is 2n what is -2n minus 2n? They only cancel out if our sign is different. If I had -2n and +2n, they would cancel. Yes, -4n. Now it's like we're adding -2 plus -2. It's going to give us -4n. That's our middle term. So,
Exactly, you gotta have them, right?
yeah. What's our final answer?
2n with a small 2
2n with the small 2.
plus, no,
Minus
take away
Yeah, take away minus
2. And
middle
4.
term. Yes, -4n. Good.
+2.
Plus 2. Awesome. That is our answer. Very nice. Very, very nice. Really quickly, I'll show you with this one because I have a little more room on this problem. It would be the same if we FOILed. If I did my first term first, I would be doing n times 2n, which gives us 2n squared. Outer n times -2 minus 2n. My inner -1 times 2n is 2n. And my last -1 times -2 plus 2. Then we would see that we have like terms and we would get the same answer, 2n squared minus 4n plus 2. So both ways work. It just is really up to you, whichever you like better. Whichever one you like better. Okay, let's look at number 3. I have 2x plus 3 times 2x minus 3. We will do the box method again. Goes on top.
2x
Mm-hmm.
plus 3.
2x and plus 3. And the side?
2x. Take away.
Good. 2x. Take away 3. All right. First box. What do I multiply?
2x times 2x,
Perfect. Which gives me what?
4x to the second power,
4x to the second power. Perfect. What do I multiply in my next box?
plus 3 times 2x,
3 times 2x, which is
6x,
perfect. 6x. I'm gonna get back in the habit of writing my pluses. think it just helps me a little bit remember what we're doing. Now we'll do the second row. What do I multiply here?
2x times -3.
Perfect. 2x times -3, which is what?
-6.
Yes, -6 x. And last one. What am I multiplying for this last box?
-6. 3 plus -3
-9.
So -3 times what number? What's the other number?
3.
3, which will be -9. Perfect. Perfect. I'm gonna pop this really quick. Okay, so we have all of our spaces filled up in our box. Do we have like terms?
Yeah.
What are they?
6, -6.
What happens?
You cross them.
They cancel. Same number, different sign. That means they cancel. Plus 6x minus 6x. They're gone. So what's my answer?
4x2.
Take away 9.
Yes.
There you go.
4x squared minus 9. Very good. Very good, Jessica. Nice.
Okay, so they cancel whatever. We have different.
Yes, when we have the same number, the same variable, but different signs, they cancel out. All right, any questions about number 3? Number 4?
Yeah.
Okay, we'll do this last one together. So I have,
R at the top of the box
good, we'll put R top
and the 1.
and
And
1.
then the R on the side
Mm-hmm.
and then -3.
-3, good. Okay.
Now, I know you're gonna do the times RR, but I'm thrown off of what the RR is.
So it's just like doing X. What happens whenever, for example, in our last problem, I had X and X. When I multiplied those, I got X squared. So if I have R and I multiply them, I'm gonna get R what? To the second power squared. Good. R squared. And what goes in my second space? What do I multiply?
The 1 and the R.
Yes, 1R plus. So I'm just gonna write plus R. Or if it helps, I'm actually gonna do plus 1R. It might be easier to combine like terms in a minute here. Now my lower left box, what goes here?
-3r.
Perfect, -3R. And last but not least,
3 times -3 times 1.
-3 times 1, which is
-3.
-3. Good. Good. Okay. What are my like terms?
None.
None.
The 3R, the 2 R's, the -3R and the 1.
We have a diagonal here of some terms that both have R. So I have -3R plus 1R. What is -3 plus 1?
2. Hold on.
2 is the correct number.
Negative.
-2R. Good. -2R. That's our middle term. So what is our final answer?
R2.
Power plus the -2R.
So should I write plus -2R or do I need that plus sign?
-2.
Negative.
We can just
-2R,
write
yeah, right.
-2R. Yes. What's last?
-3.
-3. Squared minus 2r minus 3. Very, very nice. Okay. So we have now done, this is our, let's see, we did 3 the 4th grade, 4, 5, 6, 7. This is our 7th box method problem we've done to, whoa.
So what happened to my eyes?
Okay. That is crazy. This is our 7th box method problem that we have done together. There we go. How are we feeling about using the box method?
Guys, so fantastic.
It's fantastic.
Let's wait.
Do we like it better than foiling?
Yes.
Everybody's got a different opinion. I find a lot of my students like it better. I personally, in high school, was never taught this method. I loved foiling. I thought it was so cool, but when I learned this, it just blew my mind. I thought it was so awesome.
Yeah, like some problems I can do with the foil method, but some
Right.
problems I need the box.
Right. Now, I'm going to show you something. I don't want this to overwhelm you because this is not something that you have to do on your final or even in Algebra 2. But what's really cool about the box method is it can be used for even bigger, crazier problems. We would just add more boxes. So I'm going to show you this just for fun because I find it interesting. Maybe you will too. Don't be worried if you don't know what's going on. So I'm gonna come up with a random problem like 3x to the 4th power plus 2x squared. Okay, so this is just a very random problem this came up with. We can use the box method to find an answer for this, even though it looks crazy. But instead of having 4 spaces for 4 answers, we are going to have, I believe, 9 spaces.
You gotta write a bigger box.
We gotta make a bigger box for this one. And instead of cutting it in half, we're gonna cut it, because we have 3 terms in each one, we're gonna cut it into thirds like this. So we're making like a tic-tac-toe board. I bet you guys can do this pretty well. Now, once we've got that drawn, if you're drawing along with me, I'm gonna look at my first polynomial. What would I start writing on top of my bigger box?
3x
Uh-huh.
and 4.
3x to the 4th power
2x and 2.
plus
And
2x
then 1.
squared plus 1. Beautiful. Same thing as before, we just have more numbers, more terms. And on the side, what do I write?
3x to the 3.
Mhm.
4x 2. Plus 2x.
Perfect, plus 2x. Okay, so now we have a bunch to do here. I'll give you guys a minute to copy that down. This is a lot to write. So this might be like a really good bonus question in the future. Maybe. We'll see. Okay, so my very first box in my 9 opening box right up here. Which 2 terms would I multiply?
3x and 3 to add 3x to 4.
Yes, 3x to the 3rd power times 3x to the 4th power. So let's look at our coefficients first. 3 times 3 is
9.
9. And x to the 3rd power times x to the 4th power is,
Is it 12 or 7?
ooh, what is it, 12 or 7?
7?
Make your case. Why do you think it's 7? Why do you think it's 12?
I
When
don't
you
know.
add, when
You don't know?
12.
Okay, 12 because you're multiplying. Now you tell me what you think about 7.
Because when you multiply, it's supposed to add.
Whenever we have exponents, remember x to the 3rd power times x to the 4th power. What this means is I have x to the 3rd power is x times x times x times x to the 4th power is x times x times x times x. Now we can see how many times am I multiplying x all together. If I counted them, there'd be 7. So remember, exponents, we add the number to multiply them. But our coefficients, we multiply like normal. So it will be 9x to the 7th power. Okay, how about my second box right here on the top row?
8x to the 4th power.
Which two terms do we multiply?
Oh, I'm sorry, 2x to the 2nd power times 4x to the 2nd power.
So we're not on the second row
No.
yet. We're right here.
Still,
2x to the 2nd
3x.
power and
3x
Over.
over.
Oh,
3x to the 3rd. Yes. Now we will multiply 4x to the 2nd power eventually
Okay.
when we get down here. They have to line up. See? So right now we're staying on the first row.
Okay.
So 2x squared times 3x, this actually is cubed, if you're curious, to the 3rd power. So what is my coefficient?
6.
6. 3 times 2 is 6. Good. And what's my new exponent? 5. 3 and 2 is 5. Yeah. Okay. And my last box on the top row, what do I multiply?
1 times the 3x to the cube, whatever you said.
3x cubed.
Cube.
So 1 times 3x cubed is
3x cubed.
3x cubed. It does not change. We've done the first row. Beautiful. Now on to the second row. That means every time that I go to the next term, we're using the 4x squared as our multiplier. So what am I multiplying in my first box of my second row?
4 squared to the 3x 4.
Yes, 4x squared times 3x to the 4th power. So what's our coefficient? What did you say? We said you say 12. That's right. 4 times 3 is 12. And our exponent will be
Okay. 6.
6. Good. Okay, how about my middle box?
2x squared to the 4x squared.
Yes, 2x squared times 4x squared. What's our coefficient?
8.
8. X to the what?
4.
4. Good. Look at all these different exponents. This is going to be a crazy answer. Okay, and last box in the second row. What am I multiplying?
4 squared to the plus 1. Or times 1.
Yes, 4x squared times 1, which is
4x.
4x squared. Okay, one more row. What do I multiply here?
1 to the 2x. Or 2x to the 1. 2x to the plus 1.
Yes. So 2x times.
The 1. Oh, I'm sorry, the first one. I was going, yeah.
That's okay.
My eyes went too far. I'm
That's
sorry.
okay.
Yeah.
So we're going to do 2x times
3x.
3x to the 4th power. What's our coefficient going to be?
6.
6. Good. And our exponent,
And the 4. X and the 4.
we started with
I'm down at the
4.
bottom of my eyes, I'm getting
That's
sorry.
okay.
4, 5, 6, I mean 4.
So
4,
we
5, 6,
started
6, 6,
with
6, 6, 6,
4,
6, yeah.
and now we
Got two.
have a 1 here, right? So what is 4 plus 1? 5.
5.
5.
That's why I always get screwed up with them X's.
Yes.
That's all right.
Forget it's not a time, it's a supposed to count it.
Right. That's one of the most confusing things is remembering when to go back and forth
Yeah.
between multiplication and adding. It's tricky.
Yeah, that's what it
Or
is.
we can add a 1,
Right.
imaginary 1.
Yeah.
Right. Okay, what do I multiply here?
2x squared times 2x.
2x squared times 2x. What's my coefficient?
4.
4. X
To the third power.
to the third power. Good. So we have a 1 there and a 2 there. 1 and 2 is 3. And last but not least,
2x times 1.
yes, 2x times 1, which is
2x.
2x. Woo! It's a big one. Okay.
So just say for instance, if they put another more numbers out there, the square would just continue to get
Yes,
bigger and bigger
the
and bigger.
square would continue to get bigger by more and more each time. Now we would have to figure out how to write our answer because this one is not as straightforward as what we're used to.
Right.
So whenever we write out a long polynomial, we always want to have our biggest exponent first. So what is our biggest exponent here?
12.
Oh, that's our biggest coefficient. Let's look at our biggest exponent, the little number.
7.
7, right? That's my biggest exponent. You see?
Uh-huh.
So what I'm going to do is I am going to find that and cross it off as I rewrite it so I can keep track of what I have written. So let me use a different color.
What?
So we would go first.
Yes, so I'm going to write over here 9x to the 7th power plus, what's my next biggest exponent?
6.
6. So I'm going to write plus 12x to the 6th power.
Now we got 2 the same.
We do have 2 the same, don't we? I have 6x to the 5th power and another 6x to the 5th power.
It cancels.
Do they cancel?
Not really.
Are either of these negative?
Oh, okay.
No, you're okay. You're okay. What do I do? You add them. Good. So what is 6x to the 5th power plus 6x to the 5th power?
Oh.
12. 12x is a what?
Yeah.
Are we
No,
multiplying?
no. You said add.
Adding. So what is our exponent?
10.
We're not multiplying. We're just adding. Right now I have 6 of these and I have 6 more of these. I add them together and now I have 12 of these still. X to the 5th. We don't change the exponent whenever we add, only when we multiply.
Oh, to the 5th power.
Yeah. We don't change when we combine like terms, the exponent stays the same.
Okay.
Yes. Combining like terms they're like terms because they're both to the 5th. So they stay the 5th when
They
we
stay the
combine
same,
them.
okay.
Yes.
Okay.
Yes.
Okay.
Just like when I labeled these with colors, I have 3 greens, 2 pinks, 15 pinks, and 10 oranges. If I add my 2 and my 15 pinks, they're gonna stay squared.
We stay the same,
They're gonna
yeah.
stay pink, you know. So we don't we do not change the exponent when we combine our like terms, only when we multiply. Okay, so I have my to the 5th power done. What's the next biggest exponent?
8x 4.
8x to the 4th power. And there's only one of those, so I'm just going to write it. Plus 8x to the 4th power. What's my next biggest?
Plus 4x to the third. No.
Yes,
Yeah.
yes, that is.
Okay.
Is there any others?
Yeah, 3x 3.
Okay, so we have like terms. So when we combine like terms, we add. What is 4x to the 3rd power?
Seven.
Plus.
7x
Good. 7.
to the third.
Yes. 7x to the 3rd power. We've got 2 left. Ooh,
4x2 goes nice.
good. 4x 2 or squared or to the 2nd power
Plus 2x.
plus 2x. Woo! That's a big one.
Mind-boggling.
Yep, it
That's
sure
a big
is.
number.
Imagine having to figure out how to factor this to get it back to that.
But we're not doing that.
I don't even know
Is
how to
that
do it.
algebra or geometry?
This is neither. This is like something we will not ever touch.
Okay. But somebody in the world would.
Somebody can do it.
Like Sheldon?
I'm not that person. I do not know how.
Like Sheldon?
Like Sheldon, exactly. Exactly. So,
Sheldon, my man.
that is what the box method can do for you. You can make that box as big as you want. You can multiply as many terms as you want. It works. It's just a long process.
And you gotta keep your mind open too.
Yes.
I like these better than
Then the FOIL,
no.
the factoring.
Yeah.
Yeah, the factoring, doing the reverse of this is definitely harder. It's definitely harder to factor than it is to do the multiplication part. Which is definitely why in the future I will teach this first. I think it wasn't smart to try factoring before learning this. So anyway, guys, I don't really have anything else to show you today. You're welcome to stay and work on those worksheets if you want. I'm not grading them though. The answer key's on the back if you're wanting to check your answers. If anyone has any questions for me, again, you can stay. You're welcome to, do whatever. But that is all. So, no exit ticket today. All that you have due tomorrow is day 24, 25, and 26 exit tickets. That was from Monday, Tuesday, Wednesday. And that's it. I hope you all enjoy your weekend. I'm gonna end that video there.